the absolute value of x minus a is less than delta, then f of x minus L is less than epsilon. You have to sub in what a, f of x, and L are. Step 2 is we use the delta, or we find the delta, and we use the second half of our goal to get there. Step 3 is the actual proof. So we'll say delta is whatever we found on step 1. Then we do the definition, and we state everything from here to there, and then we have to get the less than and the epsilon. Do you kind of remember running through this? Mm-hmm. So we're going to do a couple more together today. My goal. If the absolute value of x minus, what is my a?
0.
Is less than delta, then the absolute value, what's my f of x?
Limit x cubed, whatever that is.
Cube root of x. Remember, this right here is my a, this is my f of x, and this is my L. So f of x minus L is less than epsilon. So first we find delta. And I told you to get it from the second part. So if we have the cube root of x minus 0 is less than epsilon. Well, what is the cube root of x minus 0? What's anything minus 0?
The same thing.
Oh, that's what you're asking.
How would I'm trying to get x minus 0 in here. Now, x minus 0 is the same thing as just x. How would I get rid of the cube root?
Cube it.
Cube it. So that means the absolute value of x is less than epsilon cubed. And again, I want the absolute value of x because I'm trying to get this, but the absolute value of x minus 0 is the same as the absolute value of x. All right?
Something makes a body odor.
Sorry.
You.
I put on lotion to try to.
I don't think that's what it is, but
Yeah.
you kind of smell them.
My lotion's vanilla, so it's probably.
I'm hoping that's not what I smell.
All right. So step 2 is the proof. So you have to start out with the definition. And we're going to put all of this part. So if the absolute value of x minus 0 is less than delta, then the absolute value of the cube root of x minus 0. And now I have to work it out until I get a less than and an epsilon within it. So we're recreating, we're really just doing the same thing that we got done doing. We know that the cube root of x minus 0 is the same thing as, oh, what did I forget to write down? I forgot to write something.
Let blank here.
Yeah, let delta equal epsilon cubed. Sorry. Okay, so if we work this out, that is the same thing as the absolute value of the cube root of x. Does it matter if you do the absolute value or the cube root first? What does an absolute value do? Makes it positive. Does it matter if you have the positive before or after the cube root? No. So I'm going to move the cube root on the outside. Because I know that the absolute value of x minus 0 is less than delta. So this is the cube root of the absolute value of x, so that would have to be less than the cube root of delta. So I've got my cube root symbol over my delta. So we have the less than that we needed. We're trying to get an epsilon. But what is delta equal to?
Epsilon cubed.
cube root and a cube cancel, and we get the epsilon. So we have proven it. I have two more on here. We'll do at least one. If we need both, we can do them. We'll practice at least one.
Yeah.
I'm sorry.
It's my shoe.
Oh, your shoe.
Yeah, it's like.
I saw the
Smells
shoe
are
and I was
very-
like,
Smells are very much a
You
big.
guys can smell.
Yeah, not everyone stuck it.
I'm mad
Smells are
at
very much a
myself.
big, like, trigger thing.
Okay, so remember this is your A, that's your f of x, this is your L. So our goal, if the absolute value of x minus A, so x minus -3 would be x plus 3, is less than delta, then the absolute value of f of x, so that's 7x minus 9, minus L, so minus -30 would be plus 30, is less than epsilon. So step one is to find delta. And we start with the second half. What could you do here? Mm-hmm. Okay, we're trying to get an x plus 3 inside my absolute value. What could I take out? Since it's positive, we could go ahead and bring it all the way out. And then what would we do? So, that's the work we needed. Now we have our delta. So then we go into our proof. So we say let delta equal epsilon over 7. And then we write the definition. If the absolute value of x plus 3 is less than delta, then the absolute value of the 7x minus 9 plus 30, and I have to work this out until I get the less than and the epsilon. So we're really just doing the same thing over again. So we combine our like terms. And take out the 7. But we know that the absolute value of x plus 3 is less than delta, so this has to be less than 7 delta. And delta is equal to epsilon over 7. So 7 times epsilon over 7 is epsilon. Questions on that one?
Oh, I got questions. Is this the day where we can ask them?
You can ask questions. You could ask them the other day, you just couldn't complain. But you can ask questions.
Oh, I don't understand the whole second step.
The proof part?
Yeah.
Okay, so you'll start out with letting delta equal something. And it's whatever you found right here.
Yeah, I get that part.
Okay.
The part where it goes to the equal and then the thing and then,
Okay, so you understand where this
That-
line comes from?
yeah.
Okay,
And the next one.
alright, so then you got to here,
Yeah.
and then you understand I pulled out myself.
Yeah.
Okay,
It's just
so
the
then-
less than and then all the rest.
Okay.
Is what I don't get.
We've already stated early in the proof that the absolute value of x plus 3 is less than delta. So, I had an absolute value of x plus 3 here. So I said that has to be less than 7 delta. The 7 because there was a 7 in front of this absolute value.
So wouldn't it be the, little, I don't.
Okay,
don't
so
know.
I know this is true, right?
Yeah.
So that means 7 times the absolute value has to be less than 7 delta. If you multiplied each side by 7. That's what I did here. It had the 7. So I said, well, there's an absolute value of x plus 3. And I know that absolute value is smaller than delta. So this has to be less than 7 delta.
So. Why is it not in delta over 7?
That's what I did. The next step, we said that delta is the same thing as epsilon over 7. So I took this delta and I replaced it with epsilon over 7. What I would like to do, I would really like for you guys to try some of these on your own so you can kind of see where you're getting confused and we have time to talk about it and get you there. What you need to do when you're working through these is follow these steps that I printed on your last slide. So I expect you to write out the goal, I expect you to do step 1, and then the actual proof. On these, your work is your answer. So you can't just say epsilon over 2 and be done. It's a proof. So you have to write out everything. This is not something you can shortcut, okay? So there's a handout posted on Classroom with a few of these questions and you've got time to work now.
I was gonna do example 6.
I mean, you
That's what I
can.
started doing.
No.
I got homework
No,
now.
I gotta do some stuff.